All right, this is Mr. Hanna recording Chapter 1, Section 1, or Chapter 5, Section 1. This is solving inequalities by adding or subtracting. You need to read page 283 through 285. This is a nice, easy lesson. It's the same as solving equations, just no equal sign. You got to remember to get the variable by itself by doing the opposite. A small review. This is less than. Notice the smaller end points towards the smaller number. The larger end points towards the larger number. Less than or equal to, you have an equal sign underneath it. Greater than, the bigger end is on the left side and the smaller end is on the right side. Again, the smaller end points to the smaller number. Greater than or equal to, a line underneath it. Quick review of graphing inequalities. You have to graph them on a number line. If you have less than or greater than, you put a circle on the number line. That means the number itself is not a solution. I'll go into that more a little bit later. If you have less than or equal to, greater than or equal to, you put a dot on the number. That means the number is also a solution. As long as the variable is on the left side, all you have to do is shade the direction the inequality arrow points. If we're solving by adding, that means we must be subtracting from the variable. Again, don't get stuck in the habit of moving from the left side to the right side. Find the variable and move away from the variable. So I got 22 is greater than m minus 8. We're subtracting 8, so we have to add 8 to both sides. We get 30 is greater than m. I don't really like it in this form, because if 30 is bigger than m, then m must be smaller than 30. M is less than 30. That's the same, both of those. And we like this version better because then we can graph it. We go to 30, less than, so we put a circle, and the numbers are less than 30 to the left. So all of these numbers to the left, 0, 10, 11, 22, 29.99999 are solutions. But 30 would not, because 30 wouldn't be less than 30, it would be equal to 30. Now why does this work? Why can we add sames to both sides and it'd still be true? Well, if I have 6 is less than 8, we know that's true. I add 2 to 6 and 2 to 8, I get 8 is less than 10, so the inequality is still true. That also works for subtracting. If I have d minus 14 is greater than or equal to negative 19, we're subtracting 14, so we add 14 to both sides. We get d is greater than or equal to negative 5. We put a dot on negative 5. Our arrow is pointing to the right because the numbers bigger than negative 5 are over here. D is greater than or equal to negative 5 means negative 5 is the solution and every number over here on the number line as far as you can go. If we're solving by subtraction, that means we were adding in the initial equation. If I have p plus 8 is less than or equal to 18, I subtract 8 from both sides, I get p is less than or equal to 10. So I go out to 10, I put a dot on 10, and I draw my arrow to the left because that's where the numbers less than 10 are. If we have variables on both sides, we got to get the variables together first. That means you move the smaller one to the larger one. This is important. You really want to do this because it keeps the coefficient positive. If our coefficient is negative, like you'll learn on Tuesday, it changes the way the problem works. So if I have 9 minus 1 is less than 10, or 9n minus 1, m minus 1 is less than 10m, then I got to subtract 9m from both sides. It gives me minus 1 is less than m, or m is greater than minus 1. So I put a circle on minus 1, arrow to the right. There's a blue box on page 285. You need to copy that down. It gives you some words for inequalities for when you're trying to translate words to inequalities for them to solve. Your homework is page 286, 2 through 40 even.